Hello. So last night I was trying to sleep and I don't know why, but this idea of a clock popped into my head. I swear I'm not a clock solver. Please don't call me a clock solver. I'm not being the allegations there, am I? So basically this is a method to compute the formulas for every move in a pin set. And it's one that you can do manually using clock intuition if you have that. I mean, I don't really, but I'll show you kind of how it works. So I'm going to show you how you would calculate the formulas for the Zhang pin set, which I will write down now. It's got the moves UR, DR, R, slash, lowercase dl, L, and lowercase ur are the moves. I don't know if you can see that. Ooh. Yes, so those are the moves. And so the way that we're going to do this is we kind of use this idea from a simple blind method that you may have thought of yourself. So whenever we have a clock scramble, no, hang on. What we can do is we can imagine all of the clock scrambles which are just a single piece aligned by 1. So you can see everything is solved except for this one piece. It's aligned by 1. And we can determine a formula for calculating this using our clock intuition, using just the moves that we're allowed to use in this pin set. So for example here we can solve this by doing, holding my phone with one hand, do a DR move. Whoa. No, not 2. And then we can do an R with -1. And that just leaves this corner. And then we can do this move. No, hang on, that's wrong. We do this move. This is one of the moves. We have lowercase dl, and then we have just a slash left, and we undo the slash. So you can see that to solve the U piece, it's not in focus. So this column on the left will be the pieces. We're going to do 1 dr move, and then a -1 here, and then a 1 here, and then a -1 here, I believe is what it was. Let me actually just, no, okay, I got it backwards. The slash is meant to be negative, and the DL is positive. Yep. And so then the idea is we can do this for every piece. Now we can do UL. Let's think about how we do UL. So let's make UL 1 tick from solved, like so. And so we want to solve this using just those moves. And there is a way, I'm cheating by looking at the matrix, but yes, so you can do it from the back. You can do it like this. Yes. So those are 2 simul moves. So really I should know that these are 2 moves on the front. So I should really be doing (0). Please load. This phone camera is annoying. (0, 0). Okay, so for UL, we do, what is it? DR 0. And then we're going to do it from the front. So okay, here we do it from the front perspective. So you know we turn all that stuff. So that's what? Oh, hang on, I put it backwards. Okay, so what we're going to do is we're going to do a -1 turn on when we have DL up, and then we're going to put the slash pin up. Oh, hang on. Whoa. Yeah, so we're going to do a -1 with DR. Then we're going to put this slash pin up, and then we're going to do a 1 with the slash. So then the calculation looks like 0, -1, and here on the slash it'll be 0, 1. And then we can do this with all of the moves. It's quite a bit of work. All of the ones I left blank is 0. And then finally, to actually compute the formulas from all of these, we notice that with any scramble, so I'm just going to drop the phone and do some scramble. Okay, so notice that with any scramble, what we can do is we can solve each piece one by one, and we can calculate the moves we're going to do to solve this. So for example, let's just say we're solving the first two pieces, UL and U, because those are the ones I've calculated. Okay, we can see that it's not at 1, it's at 5. So what we're going to do is we're going to look at the moves we need to do to solve UL, which are these ones. There's a 1 there. And we're going to multiply them by whatever the number is. So we need to do a 5 move, -5 and then a 5. So let's do that. 5, 1, 2, 3, 4, 5. So nothing has changed, but we've solved this corner. Next, we can solve the U piece by doing, so this is -5, so we're going to multiply all these moves by -5, so it's dr, and then we apply a -5. Then we have -r, so we apply a regular 5. And then we have slash negative, so we apply +5. Then we have dl plus, so we do -5. And again, everything is the same except we solve these two pieces. And we do this for all of the pieces, and we'll notice that we do the same move multiple times eventually throughout the whole puzzle. And so because clock is commutative, we can instead just write down every move we do for each and then add them up. Oh, so the overall move, we have UR, L, C, R, DL, D, DR, and then we have the back pieces, so you have U, L, little c, R, and D. And we compute all the formulas for all of these, and then we're going to sum up. We're going to multiply all of these moves by the piece and add them all up. And then that's going to give us a formula, right? Because to see what we need to do to DR, we're going to see what we need to do to, like what our DR move is going to be. We're going to see what our DR move is for each individual way to solve each piece. And then we add all of those up, and that turns out to be what we do in the whole solution. So yeah, I hope that kind of makes sense. I don't know, because don't want to fill out the whole table. It'll take too long. It'll be a lot of work. Like I'm gonna be ending up making a 178 entry matrix. Some of these, well, okay, I think all the edges have 4 and some of them have 3. So C has 3, which is kind of confusing. Yes, well that one's got 3 as well. No, that one's got 4. So yeah, a lot of these have 3 and 4 numbers in them for this pin set in particular. And yeah, so I don't know, I hope that kind of makes sense. Like, yeah, it's just going to be UL, like the backside will just be, for this DR move, will just be UL times -1 plus whatever shows up for the rest on the backside. And then for the front side, it'll be U plus whatever else shows up for the front side. And we do this for all of the moves. Yeah, if this is confusing, you can ask clarification in the comments or whatever. But yes, so like, yeah, we can just solve one piece each, one by one. That's the basic idea, right? Is there anything? Yes, okay. So the last thing that I wanted to think about, but I couldn't figure out yet, is whether this is applicable for pseudo solves. So my understanding of pseudo, I'm not a clock solver again, but yeah, so my understanding of how pseudo works is that we're going to add a bunch of constraints to a scramble. So for example, we might have, let's scramble it some more. We might have this pseudo case, which is a very simple one, where we have a big block here. And so the constraint would be C equals R and also C equals L, right? And so when we work with all of this, the set of all scrambles such that this constraint holds, it turns out to be, instead of 14-dimensional, it's now 12-dimensional. Because, effectively these 3 pieces are the same. We've kind of gotten rid of 2 pieces. And so there should exist maybe some 6 simul pin sets with this. Maybe Zhang works. Again, I don't know this stuff. But if you had some idea of a pin set for solving 6 simul under this constraint, maybe you can apply this process. But the problem is that you can't isolate each piece under this constraint. Because, you know, if C equals R, we can't just have C1 and R0, right? R also has C1. And then you can have more complicated constraints, like you can have C equals L plus R minus U minus D, I don't know, something like that. And you might have another one, and then you have these really annoying long constraints. And yeah, I haven't figured out how to work with it, but maybe someone else can. I don't know. This is just an idea. Maybe no one's going to find this useful, but whatever, I just wanted to document it. Thank you.